Hey everybody, so in this video we're going to talk a little bit more about factoring. You should have already watched the video that is a review of standard factoring techniques to refresh your memory about how we normally factor. In this video we're going to talk about some more advanced techniques of factoring, and we're going to set up how we're going to factor with different types of polynomials, okay? And even things that are not polynomials. So the first thing I wanted to talk about is what it looks like for something to be quadratic. So we know that, so for us, a quadratic is something that has the form ax squared plus bx plus c, okay? Where a, b, and c are numbers. Okay, and this is what we're used to factoring, right? Most of our factoring questions are about things that have this form, and especially things that have the x squared type of form. Now we're going to talk about things that are called quadratic in form. Okay, now this means that they're not exactly the ax squared plus bx plus c form, but they follow that same pattern. Okay, so let's go ahead and look at some examples of things that are quadratic in form, and we'll look at the technique that we can use to really see them as quadratics that allows us to factor. Okay. Oops, I want that to be a subtraction symbol. Okay, now you can see that this is not exactly a quadratic, right? It's not x squared and then x and then number, okay? But that's what we want. We want something that has the x squared here in the first term, the x term as the second term, and then just the number term, okay? So what we're going to do is use a technique called u-substitution, okay? And what we're going to do is define a new variable so that we have that x squared x number form, that quadratic form that we're looking for, okay? Now, the first term, or the largest term in terms of exponents, is hopefully going to be your u squared term. It's this second term that we want to be our x term, right? Our second term in our trinomial is bx. So we want this 3t squared to be our x type term. So we're going to pick the variable from there, or t squared, as our u, okay? And then we're going to look at what is u squared, okay? So that would be t squared squared. Okay, so we know that when we have an exponent raised to another exponent, we multiply them. So 2 times 2 is 4. Okay, so we're going to rewrite our polynomial using this u. Okay, so t to the fourth, oops, I forgot my equal sign here, right? T to the fourth is u squared. Okay, so I'm going to have u squared plus 3, and then my t squared is u, okay, minus 10. So now you can really see that u squared, u, number, that quadratic form, okay? This is going to allow us to just factor this like normal by asking what multiplies to -10 and adds to 3. So that should be +5 and -2, okay? Now here's something that you absolutely can't forget, and this is such an easy thing to forget when you're doing these types of problems. You want to go back to the original variable. Okay, so our original variable was t squared. So I'm going to have t squared plus 5. Okay, and then I'm going to have t squared minus 2. We want to check that neither of these can be factored any further, okay? And they can't, neither one is the difference of squares, so this is our final answer, but there's always a chance that when you go back to the original variable that you'll need to actually factor further, okay? All right, let's do one more example, and I want to do an example with a trig function. Okay, so we want this to have that quadratic form where it's x squared, x, and then number. Okay, so again, we're going to use what comes from this second term as our u. Okay, so we're going to let u equal sine x. Okay, and then we're going to look at what u squared would be. Okay, so this would be sine x squared. Okay, and we do write that with our function notation as sine squared x. Remember, there's no difference except for how nice the notation looks between sine x squared with all of these parentheses and sine squared x. Okay, so when we go to rewrite this in terms of u, we know that sine squared x is u squared. Okay, sine x is u, and then I have minus 2. Okay, so this is going to allow me to factor like normal. So what multiplies to -2 and adds to -1? I think it should be -2 and +1. Okay, and then we're not going to forget to change back into the original variable that was sine x. Okay, so we'll have sine x minus 2, and we'll have sine x plus 1. Okay, so I hope that gives you the idea of what it means to be quadratic in form and how we're going to use u-substitution to allow us to see that quadratic form and factor normally. Okay, we'll do tons more examples in class, and I will see you guys then.